Today, I have some exciting news and a story to share with you about a mission that sounds like something out of a sci-fi movie. A mission that involves sending a spacecraft to a distant and mysterious asteroid, touching its surface, collecting a sample, and bringing it back to Earth. Sounds like fiction? Let me tell you that it is not. And the sample is about to arrive on Earth. That mission is OSIRIS-REx, and in this video, I will tell you the amazing story of how this spacecraft collected a sample from Bennu, an asteroid that orbits the Sun between Earth and Mars, and is bringing it back to Earth, and why this sample is so important for science and humanity. I will also show you how you can watch the historic moment when the sample capsule lands in Utah on Sunday, September 24th, 2023. This is a once-in-a-lifetime opportunity to witness a cosmic event that could change our understanding of ourselves and our place in the universe. So stay tuned and get ready to explore the wonders of Bennu with us. The mission to Bennu began in September 2016, when OSIRIS-REx, which stands for Origins, Spectral Interpretation, Resource Identification, Security, and Regolith Explorer, was launched from Cape Canaveral, Florida. The spacecraft traveled for 2 years and covered more than 2 billion kilometers before reaching Bennu in December 2018. Since then, the spacecraft has been orbiting and studying Bennu with its suite of instruments, including cameras, spectrometers, laser altimeters, and radio science experiments. The spacecraft has mapped Bennu's surface in unprecedented detail, revealing its shape, size, color, texture, composition, temperature, gravity, and rotation. The spacecraft has also discovered that Bennu is an active asteroid, meaning that it occasionally ejects small particles into space from its surface. But the main goal of OSIRIS-REx was not just to observe Bennu, but to touch it and collect a sample from it. This was not an easy task because Bennu is very small, only about 500 meters across, very rocky, covered with boulders and craters, and very fast, spinning every 4.3 hours. To make things even more challenging, the spacecraft had to perform the sampling maneuver autonomously, without any human intervention or communication from Earth. It had to rely on its onboard computer, sensors, thrusters, and navigation system to execute a complex sequence of commands and maneuvers. The sampling event took place on October 20th, 2020, after months of rehearsals and preparations. OSIRIS-REx left its orbit around Bennu and descended slowly towards a pre-selected site called Nightingale, which was located in a crater near Bennu's North Pole. The site was chosen because it had relatively flat terrain and a high concentration of fine-grained material that could be easily collected by the spacecraft. As the spacecraft approached Nightingale, it extended its robotic arm with a device called TAGSAM, which stands for Touch-and-Go Sample Acquisition Mechanism, at its end. TAGSAM was designed to capture up to 2 kilograms of regolith, the loose layer of rocks and dust that covers Bennu's surface, by blowing a burst of nitrogen gas onto the surface and sucking up the material into a filter. OSIRIS-REx touched down on Nightingale for about 6 seconds, during which TAGSAM fired its gas bottle and collected the sample. The spacecraft then fired its thrusters to back away from Bennu and avoid any collisions or damage. The whole sampling event lasted only about 15 minutes from start to finish, but it was one of the most critical and risky moments of the entire mission. After OSIRIS-REx successfully collected the sample from Bennu, the next step was to store it safely and securely in a capsule that would bring it back to Earth. To do this, it had to perform several checks and procedures to verify the amount and quality of the sample, as well as seal and detach the capsule from the spacecraft. The spacecraft used its cameras and sensors to measure the mass of the sample by spinning with its arm extended and comparing its inertia before and after sampling. The results showed that it collected at least 300 grams of regolith from Bennu, which exceeded the minimum requirement of 60 grams. The spacecraft also took pictures of TAGSAM's head and filter to confirm that they were full of material and that there were no leaks or contamination. OSIRIS-REx then transferred the sample from Tagsam's head to the sample capsule, which was located inside the spacecraft's body. The sample capsule was a spherical container made of titanium and carbon fiber, with a heat shield, a parachute, and a radio beacon. It was designed to withstand the high temperatures and pressures of re-entry into Earth's atmosphere, and to protect the sample from any damage or alteration. The spacecraft sealed the capsule with a series of latches and bolts and detached it from the robotic arm. Then, it stored the capsule in a safe position and prepared for its departure from Bennu. OSIRIS-REx left Bennu's orbit on May 10, 2021, and began its journey back to Earth. It traveled for more than 2 years and covered more than 2.2 billion kilometers before reaching Earth's vicinity. On September 24, 2023, it will release the sample capsule at a distance of about 220,000 kilometers from Earth, 4 hours before landing. The capsule will enter Earth's atmosphere at a speed of about 12 kilometers per second, creating a bright fireball that will be visible from some parts of the world. Then, it will deploy its parachute at an altitude of about 10 kilometers and slow down to a speed of about 5 meters per second. It will land at a predetermined site in the Utah Test and Training Range, a military facility in the western desert of Utah. The landing is expected to occur at around 10:15 p.m. Eastern Daylight Time. The recovery team will locate the capsule using its radio beacon and helicopter it to a nearby facility for inspection and transportation. The sample from Bennu is not only the biggest sample ever returned from an asteroid, but also one of the most valuable and precious samples ever collected by any space mission. This is because Bennu is not just any asteroid, but a rare and special type of asteroid called a carbonaceous asteroid, which is rich in organic molecules, water, and minerals that are essential for life as we know it. These asteroids are believed to be remnants of the primordial material that formed our solar system 4.5 billion years ago, and that may have delivered some of the ingredients for life to Earth and other planets. By studying the sample from Bennu, scientists hope to answer some of the most fundamental questions about our origins and our future. For example, they want to know how Bennu formed and evolved over time, what its physical and chemical properties are, how it interacts with solar radiation and other forces, how it compares with other asteroids and meteorites, and what it can tell us about the history and diversity of our solar system. They also want to know if Bennu contains any traces of prebiotic chemistry or biological activity, or any clues about the origin of life on Earth or elsewhere. Moreover, they want to know how Bennu poses a potential threat to Earth, as it has a small but non-zero chance of impacting our planet in the late 22nd century. The sample will be analyzed by scientists from NASA and other institutions around the world using state-of-the-art instruments and techniques. It will be transported from Utah to NASA's Johnson Space Center in Houston, Texas, where it will be stored in a special facility called the Astromaterials Research and Exploration Science Laboratory, where NASA keeps and studies other extraterrestrial samples, such as those from the Moon and Mars. The sample will be opened in a clean room to prevent any contamination or degradation. It will also be divided into several portions for different types of analysis, such as optical microscopy, electron microscopy, mass spectrometry, infrared spectroscopy, X-ray diffraction, isotopic dating, organic chemistry, mineralogy, and more. Some of the portions will be archived for future research by new generations of scientists. The mission to Bennu is one of the most remarkable achievements in space exploration history. It demonstrates how human ingenuity, curiosity, and perseverance can overcome enormous challenges and risks to explore the unknown and expand our knowledge. It also shows how we can use space technology to benefit humanity and protect our planet from potential hazards. The mission is not over yet, as we still have much to learn from the sample that OSIRIS-REx brought back to Earth. The sample is a priceless treasure that will keep revealing new insights and discoveries for decades to come. It is also a legacy that we will pass on to future generations who will continue our quest to understand ourselves and our place in the universe. Thank you for watching this video and joining us on this amazing journey to Bennu and back. If you enjoyed this video, please like,